Okay, welcome, welcome. I will give you some guidance on design patterns. Again, I'll remind you what they are and why they're useful, and then I will give you some exercises and I will help work through those with you. So, design pattern guidance. This is a general, like kind of high level workflow that at least me and my teams go through when we're building ontologies and design patterns. First, we, as I mentioned last time, identify competency questions, and those are used to guide ontology development and generate automated checks to ensure that answers are sufficient. They're basically questions that our stakeholders want answers to, and we code them in ways that help us design the ontology. Last time, we discussed drone tracking competency question, and I pointed out that we needed to represent all this sort of stuff because it kind of fell out of answering that competency question. And these are the things that help guide. This is what I mean by help guide the development of the design pattern into ontologies, right? We know what we need to represent. So with this, from this, we generate design patterns to address those competency questions and, as I said, inform the ontology creation. And that is this step. And as you'll note, there are arrows going back and forth through all of these because it is an iterative process. We do it over and over again and refine it. We don't seek perfection. We're often moving at the speed of mission and refining things over time. As I illustrated last time, here's a design pattern representing drone motion. I would recall I was trying to represent drone tracking like over a border or something. And so what I needed was a drone in motion process having a certain speed. It's occupying some spatio-temporal region that itself has parts that you can apply measurements to, like lats, longs, and altitude. You need all this stuff to answer a question like that. Well, as I said, we revise competency questions and design patterns and ontologies, and we do this through consensus building exercises. At least that's what I call them. And they're exercises where ontologists and domain experts, or generally other stakeholders, work towards agreed understandings of terms, definitions, questions, etc. And this, again, it's an iterative process, and whatever agreement is reached is meant to be added to the ontology or the design pattern, or maybe even to new or old competency questions. And with the goal being that we want domain experts to be able to speak the way they want to speak in their domain. They are the experts. We don't want to try to prescribe different language use for them. We just want to be able to represent the way they're talking in our broader, more complex models. There's some strategies, if you wanted to see more details, some strategies that I employ when I'm using consensus building exercises that have to do with like meetings with stakeholders and like Likert scales and forcing people to vote on things and making them feel uncomfortable and then like tell them they can't talk about things we've already voted on, project management sort of stuff. If you're interested, I'll let you read that from a grant that we recently got accepted. Now, that is, again, that picture is kind of like a general high-level overview. When we're thinking about developing design patterns or just ontology development in general, you should think in terms of these steps, like competency questions, design patterns, ontology generation, consensus building throughout. All right, so again, high-level overview. Before we get over into the ontology development, the way I want you to, the design pattern development, the way I want you to approach it, there's a little bit of a preliminary. You guys believe in mermaids? My daughter does. She thinks she's one. Mermaid is a flavor of Markdown. So Markdown is a popular markup language. It's like a text encoding system like HTML. You'll be using Markdown in GitHub. Whenever you're like GitHub, when you're making comments or issues or something, you can use you're actually in many ways using Markdown, which is a way to like encode with certain scripts or text syntax that manifests in ways you might expect in like a Word document or something. So if you put like pound key header 1, you get this bold-faced high, like larger font or larger text over here. You can have en dash over here. That I guess it just means en dash. That's silly. But you can also put images and block quotes. And so it's basically a way to code. And this is how you would write, by the way, on the left, this is how you would write your comments in GitHub if you want it to manifest like that. And they've got like in your comment bar, or in any of the input screens, they have like a text and then they have a preview like button you can click on and go back and forth. So you'll see the left side and you'll see the right side if you want to see what it would look like when you actually click commit.
Isn't this how you should always do your README file for your ontologies?
Yeah, this stuff would definitely, like, you'll certainly be using Markdown and README files. So README files are usually files that sit in little repositories within GitHub, and they have like the .md file format, which is Markdown. And if you're encoding information in that README with this syntax, it will populate over there as the imagey sort of stuff, or the formatting sort of stuff you see on the far your left. Is it? You're right. But in any event, the READMEs though, they're useful because if you have those files in your repository, when somebody comes to that repository, the README populates immediately. So it's like a landing page. So that's often a place where people will put information about what the contents of the directory or the repository, what you're supposed to do with it, like guidance on how to contribute, stuff like that. But yes, all this uses Markdown. Now, why am I talking about Markdown? I asked you if you believed in mermaids. Well, mermaid is a flavor of Markdown that's specialized for representing diagrams. You'll be using mermaid to represent design patterns. That's the upshot of this. And you can see an example here. This will take you, there's tutorials. There's very good documentation for this online. I have the links right here in the next slide, but you can kind of go play with it and you can get accustomed to it. It's not that complicated. And you can always just ask GPT to write it for you if you want. But here's an example. If you just wanted to represent part of BFO, like I've got entity, continuant to current, etc. Right? This is the hierarchy that you would see if you looked at BFO. And here's what it would look like represented in mermaid syntax. You've got like a graph left to right, head to tail, right? And then you've got a code that says call this an entity. And right here you've got like colon BFO. That's sort of like a input formatting that you can use to color or change the shapes or something. If you look down here, you define a class and you say fill it with this color in this format. And when anytime you have the colon and then identify that class, it'll populate in that color or with that format. And then you just put an arrow and then you encode with a different number so the syntax doesn't confuse itself, and say there's a continuance linked to specifically dependent continuance, etc. Go on and so forth. And then that will populate in here with these arrows. So again, straightforward. It'll take you a second to play around with it, but just do that. It shouldn't take too long to figure it out. And incidentally, like you can, if you want to break lines, you could just put break BR, which is how you get like generically dependent continuant with continuant on the second line rather than one long string. Now, but you'll find more information about that when you play around on this very useful live editor. You can go to right here. You can plug and play. You can check it out, and you can also see the very helpful tutorials on the mermaid site. They've got all sorts of stuff you can represent, like flowcharts, sequence diagrams, class diagrams. I believe it's the class diagrams that I'm playing with here. That's how I typically, when I'm dealing with Markdown or dealing with anything that encodes Markdown, I'm typically using mermaid and this syntax to do it. Why? Because I can easily translate this syntax into JSON and OWL and RDF. I can so this is a way that I use, this is a strategy I use to go back and forth between like RDF and diagrams, because I don't want to type all this stuff up all the time. I want to file, I want to be able to look at RDF or OWL and just like plug it into a script and have it generate this sort of stuff. And so, but I also want to be able to generate RDF and OWL from this sort of stuff. So this is why I'm encouraging us to put these design patterns in this format, because I have tools that will allow me to generate whatever we need from them. Does that make sense?
So, but mermaid wasn't designed for OWL 2. It was designed.
No, not at all.
Okay.
I had a student and I last summer worked on a very complicated script that plays with this because I foresaw this class. I'm a long-term player. Yeah.
Is that something that interacts with GitHub as well?
It does. Yeah, you can generate, you can populate this sort of stuff in the README files, for instance. But for today, let me talk a bit about some guardrails for design pattern construction. I'm gonna be a little fast here because I want to save time or spend some time on the hands-on exercise. But At least initially, I want you guys to start modeling within the context of basic formal ontology, which you see represented here. It means you have entities. This is like all of the things. Then continuance and occurrence. Continuance are things that exist in time, like me, my daughter, that table. Occurrence are things that exist over time, like me talking, or my daughter's life, right? Extended. Under continuance, you have independent continuance. These are things that don't depend on anything for their existence, like me. I'm such an independent dude. And they're in contrast, that's a little bit loose, but like they're in contrast to things like other types of dependent entities, like generically dependent continuance, which you can think of as like information that is about stuff. And then specifically dependent continuance, which are like qualities or dispositions that have to have a bearer. Like, pardon? Color would be a quality. In one reading of color, it's a quality, right? Like the quality of an apple, right? Redness. An example, and here we have quality right here that falls under this. We also have realizable entities. The realizable entities are like the properties that independent continuants have that kind of ground whether the things that they can do. Like salt is soluble, and it carries that around with it all the time, whether it manifests it or not. A piece of salt may never come in contact with water, in which case it would not be solubating or whatever the word is. But if it did come in contact with unsaturated water, it's soluble, right? And this is part of its structure. Like it's a material, it's an aspect of its material structure. That's the reason why it's soluble. In fact, if it lost this property, something about its material structure would change. And because of that, we call that specific type of realizable entity a disposition. Dispositions are materially grounded, like in the salt case. These are in contrast to realizable entities like being a professor. I have a role, we call it. So professor role, or Barry's Julian Park chair role. Hold on, role. And these ground things that I can do, but they're not part of like our material basis, right? Like our material structure. If I got fired today, I couldn't do certain things anymore, like grade you, but nothing materially about me has changed. I might be crying, but other than that, yeah. And then under disposition, again, that materially grounded realizable, we have functions, which we'll talk about quite a bit later, but these are dispositions, and so they're materially grounded, but they sort of are the justification for why certain things exist, like a knife. A knife is designed to cut. Its function is cutting. That's why it exists, but it's a disposition of the thing. Now, in contrast, so these are all like qualities and things that adhere in like independent continuous. We also have in the independent continuous side, we have material things and immaterial things. Material things are just what you think. They have matter as parts. Look around you. It's everywhere. You can see matter. It's like, well, you can see the qualities off of matter, but you get what I'm saying, like material stuff you can touch, you can roll. We have objects, fiat object parts, and object aggregates. Go ahead and ignore those last two for right now. Just think about objects. Objects are material things that have boundaries, like me or this table, right? With that, I'm going to jump over to immaterial things. These are a little spookier, but not too spooky. We have sites and boundaries and spatial regions here. Boundaries are linked up to those objects I was just talking about. Things have boundaries. I have a boundary, right? It's right here. It intersects with my environment and all that good stuff. In fact, there's a boundary that keeps me together, a boundary that keeps you together, etc. And I'm not like flying off in different atomic particles because of my boundaries, partly. Sites are things like the trunk of a car or the airspace above an airport. We talk about these things all the time, right? Like the trunk of a car, there's one way of thinking about it. It's like, oh yeah, listen, there's like atoms in it, right? There's like atoms and like bouncing around and stuff like that. Well, not exactly, right? Like the site itself or the trunk of the car, those atoms can come and go. All of them can come and go. All the material stuff can come and go. The site's still there. How do we track that? It's like this immaterial thing that we're picking out, right? It's the site. It's this trunk of the car. It's not exactly identical to the matter that would come and go through it, right? So, and this is itself contrasted with spatial regions, which are notoriously vexed in BFO, but you can just think of them as like there is a background space that things sit in, whether they're sites, whether they're material things, all this, it all sits in the background of space. And I'm sorry, Obi, I can't say much more than that. But this is all, again, so this is the continuous side. These are things in space, right? As I said, over here we have the stuff that exists over time. And here we have processes like me speaking right now, or you baking a cake. Those things exist over time. And then histories, which is like the entire complete set of processes that go on for some object, like me. My life is a history, right? It's going to be a great one. So far, so good. Processes have boundaries, beginnings and ends, like births and deaths. And they exist over time in temporal regions. They could be like instances or intervals. Instances being exactly what you say or think, and just like right now, that's where the boundaries live, and then intervals being where like extended processes occur. And then lastly, we connect all this stuff together into spatiotemporal regions, because that's just as I said, you know, space is where all the stuff sits. Similarly, time is where all the things that extend over time sit. We connect them together with space-time. It's like, you can think of it like a block universe, 4 dimensions, 3-dimensional things moving through this 4-dimensional space. And that is BFO in a nutshell. You're experts now. Now, check this out. I want to highlight an important principle for guiding you into creating design patterns. I'm sure you're not going to remember everything I just said. Don't worry, you'll get it over time. But this thing I want you to keep in mind. Independent continuance, material stuff. The scope of BFO is space, time, and anything in it. As a litmus test, anything in space and time must have some causal impact on other entities in space and time. It's called the Eleatic principle. It sort of underwrites, so like a metaphysical principle from David Armstrong, it underwrites a lot of what we do. But this is sort of, again, our litmus test. If something is in space and time, it has to have some impact or potentially have some impact on other things. Otherwise, what? Causation is irrelevant, right? So material entities are paradigmatically in space. And nearly everything in BFO traces its dependence back to material entities. This is the design pattern part. Just about everything, and certainly for everything for what we'll be discussing with design patterns here, almost everything traces back here. Generically dependent continuants are concretized in specifically dependent continuants. So like information is concretized in qualities, right? Processes realize certain qualities or specifically dependent continuants, or certain realizable entities, which are specifically dependent continuants. And specifically dependent continuants are born by independent continuants in every case. There are no cases where there are SDCs that are free floating. They're always grounded in something, like some material entities, usually almost always material entities. So as a design pattern principle or rule of thumb, when you're building these things, think about it in those terms. Try to trace it back. And a great way to try to trace it back is to trace it forward. Start with material entities. When you're trying to design or create a design pattern, you're given some competency questions. Start with describing the material entities within the scope. List them out. Then think about the qualities they have. Then think about what they can do. Then think about what underwrites what they can do, the realizable stuff. And then lastly, the information we use to talk about 1 through 4. I'll give you an example. Material entities within scope. A missile. Describe a missile, a given missile, with all of its material armaments and whatnot. Don't think about what it can do. Just think about its structure, its engineering structure, and all the matter and parts that compose it. Then think about things like it's how long it is, not descriptions of how long it is, but like its length, its weight, its color, stuff like that. Then think about what the missile can do. Like depending on whether it's propulsion or not, can it be fired or can it fire itself, right? Like, can it shoot out on its own? Does it have this sort of capability? Does it have combustion going on? Can it blow things up or can it just like drop payloads? I don't know. And then think about what sort of capabilities, abilities, realizable entities it must have to be able to ground the things that it can do. If it has a propulsion aspect where it can shoot itself across the globe, what sort of dispositions must it have to be able to do that? Some kind of like proportionally disposition. More likely a function because it was designed to do it, right?
John, would range be a,
Yeah. Well,
capability?
range might get into 5, which is a measurement or like an idealized measurement under certain conditions of what it can do, right? Now, but there's an ambiguity here, and this is important. So you could describe, and this goes on with all the qualities and dispositions too. You're gonna encounter this again and again, this ambiguity between information and the thing that information is about, because we often talk in both ways. You can describe the range of a missile as literally how far it can go. Or you can mean by that like the missile itself in a given firing, or you can mean like some idealized under certain context specification of how far under those conditions it can go, right? One of those is information and the other happened. Does that make sense? This happens, this is confused a lot. This is probably one of the biggest, like 5 contrasted with 1 through 4 is probably one of the biggest modeling confusions that happens. I've been in conversations where somebody described a blueprint for an engine, and they told me that the blueprint for an engine was of the same type as the engine itself, namely a material thing. At which point I said, blueprints don't have mass in that way. And the engineers on the call were like, I hate to admit it, but I think John is right. At which point I said, I can't be wrong about everything. Yes, you have a question?
Yeah, I was gonna ask, is it like what the missile should do versus what it actually did? Is what the point you're trying to make
So,
between 5 and
Often we will put things that way. We'll say something like, we designed this engineering artifact to do these things. And so we can evaluate its, like, whether it was done correctly against those standards. This is why I was gesturing at functions, because functions have this normative aspect built into it. Like you can malfunction, or you can like not satisfy the constraints laid down for the function. Like you can have a bad knife, right? Or a bad missile. And so that's a way to tease this out. We do talk in that way. And that does get some, it's not far off from what I'm describing.
Okay.
But certainly like the broader classification is like information about it or measurements or descriptions of it. You could, for instance, create a knife that is used to be a screwdriver, and you can describe how good it is at being a screwdriver. I sometimes use knives as screwdrivers. Now, that wasn't what it was for, but I can describe it. So there's a contrast. So does that make sense?
yeah.
Okay. All right, with this, your turn. Suppose you've been given the following competency question to answer. How quickly are shipping containers transported by Walmart's truck fleet over a given fiscal quarter? Leveraging the BFO hierarchy, Eliatic principle, and the guidelines I gave a moment ago, which I will circle back to right now so you can just watch them or look at them while you're doing this. Work in groups to provide a design pattern that aims to answer this question. I'll give you a minute so you can write this down.
All right, can you see my screen?
Yes.
Okay. All right, so the first thing we did, we tried to just stay top level here with BFO. So we have continuance, so we have independent continuance and specifically dependent continuance. We need independent continuant because we need material entities, obviously. And one of the material entities would be a truck. Another material entity would be any of the things that we would ship would all be material entities, but we only have truck here. We also need immaterial entity because spatial region is important, like the area of where we ship, like the United States. So that's important. Then we need specifically dependent continuance because we need qualities. Off of qualities, we need something like capacity and then something like truck capacity. If we're only caring about like a fleet of trucks, we need realizable entity because trucks are going to have roles, and they're going to have dispositions because trucks are going to have functions, like the function of transport. And then we need process because we need something like active transport. I had a hard time thinking like BFO and not in the CCO world. So these truck and CCO, these aren't like CCO things. And then we need temporal region because we need like a temporal interval. And then we need like a transport temporal interval. So, so we need to have, what did Tim, what did Matilda say was her transport interval thing, her interval one?
Well, I mean, there's fiscal quarter was in the question.
Yeah.
So, and I think she has that in her hierarchy structure. So that was the time.
Okay. So yeah, so a temporal interval will be the fiscal quarter. So that's a basic start for us.
I like it. I like it. Are there any questions about this? Yeah.
So
Makes a lot of sense.
I think it's interesting looking at the approach.
Yeah.
Cause I don't know if this is the case, but it seems like you guys started at the classes that you would need.
Mm-hmm.
We did not.
Okay.
We started literally at the material entities.
Yeah.
Oh, that's where we
Yeah.
started at BFO. So we started, okay, we need continuance and we need occurrences. And which continuance and occurrences do we need? That's where we started. And we worked totally top down. Yeah.
Yeah, I think so. Jay is an experienced modeler.
No, I wouldn't say that.
You are. So Jay is an experienced modeler, so it may not appear that he was doing something similar to what you described, but I surmise, I assume, I think, correct me if I'm wrong, that Jay and the rest, there are several experienced modelers, that Jay and the crew here, they were looking at the bottom level through BFO as a lens, and so I suspect they were doing bottom up, but with the top level in mind, and that's why it looks like the top level. So it's an.
Yeah, I think you could say that. I think Matilda definitely looked at the bottom up, and I was doing top down, so we were trying to meet in the middle somewhere. Yeah.
So great. Yeah, this is the top down, bottom up, middle in strategy on display, I think. I love it. Like, and this is how I model myself. Like I have in mind the specific things I need to model, but then how do I carve up the world with BFO or Common Core, which is an extension of it that they mentioned. Do you guys want to share what you came up with?
I mean, sure, we had, our list of material entities. With containers, trucks, roads, warehouses, drivers, yard trucks, stores, and I kind of put in parentheses because we didn't think they're material necessarily, but departure site, arrival site, midpoint sites. And then we had record sheet because it's not the records, but whatever the hell is the storage material for the records. And then we had bridges, and we were kind of there because they can cause a lot of problems with routing trucks. And we spent a lot of time on that, reading out things that aren't really that important to transport. So while we were doing that, we came up with something that isn't a material entity, but like not a definition, I guess, but like a description of the departure point and the arrival point. Because the departure point, we talked about like, well, do we need what we're shipping? No, it doesn't matter.
Right.
It matters when it leaves.
Yep.
When does that start? And we said when it gets unhooked from the dock door to be moved wherever. But as long as it's hooked at a dock door, it's not in transport.
Right.
So it doesn't count for the time. The arrival would be point is when it's hooked at the door. And then we did qualities. We were kind of just going through the qualities of the different material entities that we had, which a lot of it's mass, volume, size,
Sure.
length, whatever. And then we ran into a thing with a road, which is, so we have length, we have width, we have grade, which is important because not all trucks can go down all roads. But we were thinking limits. One of the things I don't know is a quality of a road is clearance height.
Okay.
Because that sounds like a quality of a space above a road.
Yeah. Let me where was that?
You know, it was interesting, John, when he was like, well, we have records, but we don't know what they are. Their point, that's exactly why you need CCO, because they have information content entities, and then Barry's favorite thing, which is an information bearing artifact. And that's what you need. But you knew you needed them, but you didn't know what to call them. That's really
that's a very good point. Like, again, as we get further and further down into extensions of BFO, you'll see a lot of the content that you're looking for is already there. For this exercise, I want you to mostly trying to focus you on training the specific guardrails, like through the specific steps. But here's something that came out in your description that I want to kind of hammer. So the competency question. You gave a lot of info. How much did you need just to answer that? What did you need to answer that? I feel like you had a lot that you might not need. I mean, there's a way to model this pattern, like a model pattern that is maps the whole world. I'm inclined to that myself for reasons I'll get to in a second in the rest of the slides. But there's also, and this is not to say that you're wrong at all, okay? Because as you'll see in the next slides, I'm not saying you are. But it's important to think about, like, or at least keep that balance between like what's the full picture and what do I need to answer this question? Because and part of that is because we're often modeling new things and we don't have time to boil the ocean. We don't have time to model everything. We have to move quickly in what they call an agile way, iterate over and over again when we have time. But right now, answer the questions that we have before us, do what we can in the limited time we have. I say this and highlight this because it's very easy to get bogged down in very interesting questions about like subtle relationships among entities, like whether viruses are alive, or what a record is and how it's different from recording or something like that. They're like,
is really important, right, John?
absolutely.
Yeah, and having somebody in your group, like I have somebody in my group always that makes sure I don't go down rabbit holes too far.
Hey, Tim.
Yeah, because like when you guys are talking about roads and what type of roads can trucks fit on, like you're really starting to go down that rabbit hole.
Yeah,
you know,
yeah.
which isn't bad.
It's not
but,
bad at all. No.
you know,
I mean, these are fascinating questions. And one of the things I like to say to, philosophers or those who are philosophically inclined is like we inhabit and swim through fascinating questions all the time. That's what we do. And so in my experience, it's a bit easier for us after we're practicing this to sort through the fascinating questions that are relevant from the fascinating questions that aren't. And sometimes our scope is bigger than what you might expect. You're like coming at it from an engineering lens, and that's valuable. And it's one of the reasons why our background is valuable. But we also have that negative side where we can say, listen, we don't have to talk about whether viruses are alive, Alex Deal. I don't know why you keep bringing it up. Stop. Come on. But this brings me over to complex versus simplified patterns. So engineers, ontologists often work with developers who need to deploy what we do in software systems or architectures. Like we are often building models and implementing them in like text files or RDF files. They don't do anything on their own. It's not code. Ontologies don't execute, right? They're not code. They're just like frameworks. Now you can do things with them. We can do things with them. We do things with them. Developers do more things with them, and we want to help them do things with what we build. They don't always need the full design pattern that we make. They don't always need the full picture of the world. Even if we're being careful just trying to answer the question, like the competency question, they often don't even need the full formally correct picture that we give them, putting aside whether we're trying to model all of the things. Now, we, in general, like at least as I will train you as you go through this department, I will train you to be very fast at modeling a lot quickly in a short amount of time, because ultimately we need to map it all. We need to represent it all. And the way this works though in practice is you get some sponsor who tells you I need to answer these questions. You build models to answer those questions, or you put together models that you already have to answer those questions. And then given the rest of the time you have, you model the rest. And then when you have the time later to warrant and justify continuing modeling the rest, you go back and continuing to model the rest, because ultimately what we want to do is model everything, because like I said, I want to be immortal, and we're not going to get there just by modeling sponsor requests. So, but you can't model it all at once. It's an iterative process.
So, John, because not all questions need ontologies to be answered. Some are easier. Like, I'll give you an example for your roads and everything, right? So say if you use Waze and a company uses Waze, and you know that over time, whether it's bad traffic, whatever, Washington, D.C. to Buffalo takes 4 hours and 32 minutes. And they've gone over the analysis of hundreds and hundreds and thousands of trips, and they're like, takes 4 hours and 32 minutes. Now all of a sudden, you boiled all of that modeling down to one specific instance, which is a time interval.
Yeah.
All you need to do is plug in the time interval of 4 hours and 32 minutes. And if you go below it, okay, good. If you go a little bit above it, fine. You're probably within a tolerance. And now you didn't have to model any of those things about the size of roads and which roads trucks can't go on, because you know they're using GPS systems that will make sure they go on roads that they can go on.
That's exactly right. It's a great example. Absolutely. Yes, Mike.
So the most simplified way you could make it is if you looked at the material entity and just said shipping container. Right?
Not exactly for this case, because there is, but it will partly depend on what the stakeholders want out of that competency question. So if they actually are wanting you to represent like the amount that was transported, or the fleet, or the size of the fleet, or something like that, over a given fiscal quarter, they may not need the time stuff. They may just need a number associated with what was transported. That may very well be the case. They may also want you to represent like roads or something like that. That may not be built into the competency question directly. Of course, there may be sub questions that come out of conversations with the stakeholders, in which case you can get clearer and clearer about that. But at a high level, I think it's pretty easy, straightforward to give them what they need to answer that competency question I put on the board, right? So I think that's right.
Yeah, it's not like they're asking for the capacity of the fleet.
Exactly.
Right?
Yeah.
They're not asking for.
They're not asking for the arrangement of trucks over time as they move from one location to the other, and whether they go up the hills and down hills. They don't care about any of that, at least for that question. Now, ultimately, and this happens a lot, as I will talk with stakeholders or something, what happens when we work through these and we get really clear about what they're asking for, it's not uncommon for them to start wanting stuff like that, because they're starting to see things that they weren't initially thinking about as we get clearer and clearer on what they initially were requesting. That happens. And so in those cases, it's good to actually have a more complicated model in your back pocket, so you can on the fly say, well, actually, I can model all that really easily. You were paying me for it and you didn't know it. Something to that effect. But what a nice surprise. Let me jump over here in the short term when again, we don't need often, the developers don't often need the full pattern. So in the short term, we have to be able to give them what they need. And you'll hear this sometimes described as like, I hear developers, and I will talk to them like this too. They want the fewest numbers of edges and nodes that I can give them. I want, like full, like fleshed out edge node graph semantics, like linking this and that together. And they're just like, give me the fewest nodes and edges possible. Because the more you put in, and you can think about it from their perspective, the more nodes and edges you give them, the more work they have to do to implement it. And they, over time, will build resentment. It will manifest in meetings and et cetera, and on Jira boards. And so
John, in this case, like shipping for Walmart or shipping for FedEx or whoever, they really don't care about what you're shipping. They really just care about the volume and the weight maximum range. That's it, because that's what a truck has, a maximum weight it can hold and a maximum volume it can hold, and that's all they care about. And then it's just a temporal interval. It's just how much time does it take to ship it.
That's right. And this is why I didn't say what they were transporting at all.
Yeah, because it doesn't matter.
Yeah.
So,
Yeah, Matt.
question.
Yep.
So to kind of try to figure out the minimum, right?
Mhm.
Why do they care about the volume and weight?
Why do-
Because
yeah.
to some extent, the question was just about equipment. And
Mhm.
I was thinking more, like when I thought of size, I was thinking of time in yard,
Mm-hmm.
because they have to move them, they have to put them back, blah, 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 blah. But to an extent, I kind of see, like, do we care about the mass of the containers?
Mm-hmm.
If I'm stripping out, like, anything that happens on the road,
Mm-hmm.
can I also strip out what it is that's on the road besides container?
You can punt on this, because one of the first things I would have asked the sponsor who had this competency question is, what do you mean by quickly?
I mean, yeah.
And like, they may have a model already for what they mean by quickly. They may have a standard that then takes into account that sort of stuff, or they may not. And then what they mean by quickly might be a little chaotic and all over the place. And that will be a sort of thing that becomes clear as we work through the model. And they may, and then again, this has happened before. They may realize that the internal models for what quickly means aren't that good, and they need a little more help. and are willing to help let us play a little around a little more to help them get clear on what they meant by quickly to begin with. But that wasn't even apparent to them to begin with because they didn't have a model in which the gap was obvious. Yeah, Ian?
So in terms of like speed of mission deliverables, so you
Mhm.
start with a simplified design pattern, because that's all you have really
Yeah.
the time to come up with.
That's right.
As long as we're, conforming it to CCO or whatever
Mhm.
standard that we're working with. I mean, that kind of guarantees that we can later expand that up, and it's not just like you start from the top and.
That's right.
Cut off a little slice of it.
That's right. And as you'll see when we're in CCO, a lot of the work is already there to help you. So like if I'm in a sponsor meeting and they realize like quickly is underspecified, I don't actually have to go often and like rebuild things, or I can say, well, let's poke around this very well-defined, complicated hierarchy. Look at all these things we can use. And they're like, wow. And they think I did a bunch of work and they're like, this guy's a genius. And I'm like, thank you. I'll take it. But really, like Ron and Mark and Alex are working on this for a while. Let me finish this real quick. Called the full design pattern ontology engineers are trained to generate. And I will be training you to generate as the complex design pattern, and call subgraphs of complex design patterns that aim to address specific user needs, namely developer needs, simplified design patterns. Our task is to show how to construct the simplified ones from the complex ones so we maintain a connection from what developers need to know or need now to what they will need in the future. Recall this one from last time. This is representing a path taken by a ground vehicle over some geospatial region. This is from Common Core Ontologies. It's one of the design patterns that's in the Flores paper we published. You have a truck participating in active vehicle use that occurs over on a track and has parts like process parts separated over time. And you have points at which that track has parts, and it's traversing over those points over time. It's complicated. You even have like things, geospatial regions locate the location of, or that are the locations of facilities, and you have other geospatial regions that are locations of cities, etc. So it's a kind of a complex. If you hand this to a developer who just wants to represent a path taken by a ground vehicle over some spatial region or geospatial region, they will, well, first they will get mad at you, and then they'll laugh, and then they'll probably go tell your boss. Developers may only need, in fact, they may just need something like this. They may just need a truck participating in an active vehicle. This will be something you need to work out with them to see exactly what they need. But it's not uncommon that this be all they needed. Now you work on, to the best of your ability, you work on the fuller pattern. You just don't have to give it to them. You can cut from the whole cloth, I like to say. Keep that metaphor with you. I build big models and then I cut the smaller models that they need from that whole cloth. And that way I know I can trust that I can put that little model back in the big one, or at least there's a semantic connection between them. I can always go back. If you go the other route, if you just build the little models, which is what lots of folks do, then building the bigger model is a problem. That's a silo. So we build the whole thing as much as we can, as big as we can, and then we cut from the whole cloth. That's the method. So this is acceptable. In the actual ontology artifact and given computing system, we cut this part of the graph from the larger graph in the preceding design pattern. Just semantic, like it's this, we can just cut the graphs. It's not a big deal. You can make their release processes, you can churn these things out. The rest is simply adopting configuration management strategies to ensure that as there are changes to the graphs, they are in consonance. And that would lead me to this other exercise where I ask you to cut out this our shipping containers transported by Walmart's truck fleet design pattern from the full pattern that you are playing with, but we will do that later. Thank you.
Question,
Yes.
what's the question you asked to determine what the developer needs there? Whether or not it's just active vehicle use or the larger one? How do you get to that? Because I could see us building out the larger one and then going back and him, or her, the developer just saying, I just need active vehicle. And we'd be like, well, we
Absolutely.
wasted half our day on this.
Yeah.
How do we get to that?
Yeah, what I do, so I've been known to grill developers early on for this reason. And I tell them initially, I'm like, I'm going to engage in something with you for a minute because I don't want to have to come back and redo my work and waste your time. And so they're usually on board with that. And so what I do is I basically ask them direct questions about, not just about what they think they need, but about their architecture. I want to know how they plan to implement what they're doing. And I want to know as much as I can about the data they're using and how it interacts with the systems they're using it in. And typically, like getting that picture of the architecture they're working with and their tasks, that's what gives me the like what I need to know to give them. And so I will build a bigger pattern, but like depending on like one, what they're asking for directly, I give them that specifically too. But then if with respect to their architectures, like they may not be able to represent logical connections. That's pretty common. Like they may at best be able to represent like taxonomies. And so I just give them taxonomies. Now, on the other hand, I've been in situations where folks have only what they really wanted ultimately after talking through this and what they could really only represent is like a baseball card.